Our next session is Beam Me Down Scotty, using the cloud for live streaming from the space. So if you recall that session we just saw with the live stream, now you get to hear about how to do that. So we're going to learn how live HD and 4K images are transmitted to Earth despite the significant challenges of distance, speed, and technology. We'll also learn how the images are distributed once they are on the ground to create interactive conversations with the ISS astronauts. So please join me in welcoming, and I love this title, Technical Marketing Engineer Josh Winstead of AWS.
Thank you.
Thank you.
Yeah. Good afternoon, everyone. My name is Josh Winstead. Like you heard, I'm a Technical Marketing Engineer for AWS. Came from the Elemental family, then that was rolled into with AWS about 4 years ago. So my background is in broadcast engineering and TV station operations, and then over time it evolved into streaming and live content. So what we're going to talk about today is what you saw earlier this morning, which was the live interaction with the space station, and then what we did previously and the accomplishments and iterations of that project. So first of all, we were approached by NASA, let's see, it was a little over 2 years ago, for help with a 4K transmission. And at the time, Elemental Technologies, we were making hardware encoders for providing 4K content streaming. And we said, okay, well, we can work with you and sit down and bring this together. So what we did was essentially plan that workflow and then implement it at NAB in 2017. So on the slides, what we'll do is we'll run through and walk you through that process. But essentially what happens is, first of all, we have to get the content down from the space station. And so the ISS, as you know, is a moving target. NASA has pretty well perfected that communication link between the space station and the ground, which includes the TDRS system. And the video and audio we're going to have to ride on those traditional linkage paths. And so with that process in place, what we had to do was say, okay, can we get the 4K compressed enough to get it down, and can we maintain the quality and preserve as much of that picture quality as possible? And so what we did was custom made a Elemental encoder by working with NASA to ensure it meets the parameters. And we had to take what was traditionally a very large 1RU full rack size GPU encoder and then compress that down to a CPU only encoder that would allow us to match the power requirements and, of course, the safety requirements that NASA requires for all their content or all their hardware in space. And so with that, we were able to sit down with our engineering teams in Portland, Oregon, and craft a solution that allows for this very specific one-off encoder that runs on off-the-shelf software that we provide to you as any of our consumers who would use the devices. And so that encoder had a 3G, quad 3G capture card in it, and the red camera was outputting quad 3G to us, and then we had to send audio down on a separate path originally. And so that separate path was the traditional HD path that you saw this morning, but the video on the 4K side was going down a different path. And so once they got to Johnson, we had to take those and then combine them together, sync it all up, and then send it to us in Las Vegas. Now at the time, the issue with that was we were going to need to put it back on satellite and get it down to the Las Vegas Convention Center because we just didn't have very viable options for doing 4K at the time with that. And so once we got all this set up, we were able to launch the encoder, send it up to the space station, provide it to them and provide the instructions for them to get it all plugged in. Turned it on, everything worked great, which was a relief within itself because you never know what's going to be damaged in this process or what could be irrecoverable from the damage of that. So with everything turned on and running, we were then able to test and fine-tune and tweak the encoding profile to get the content down. Once we did that, then we had to go through the process of designing how we're going to do this live event with them to prove out the POC and then provide the 4K content for the audience there in Vegas. And so what we ended up doing is working with NASA over months to fine-tune this process and really dial it in so that way we could go back and use this again later on as well. We didn't want it to just be a one-shot only solution. We needed this POC to provide us a foundation to work from and iterate from moving forward in the future. And so because of that, we spent time with them to lay this all out and perfect it. And like I said, because the audio was coming down on the HD link, 4K coming down on the video only link, we had to do a fair bit of syncing and time delay on the audio to get everything back in alignment at Johnson Space Center. And so once we did that with the 4K video, we were able to put that back into an encoder, one of our elemental encoders, our GPU ground encoders, and then send that to us in Las Vegas. And over the satellite, decoded back in Las Vegas for the presentation, we produced the entire show around it, and then re-encoding that whole thing again, and then making it available to our viewers. So as you can imagine, all of these steps in the process were really leading to a lot of delay at the time, and we were incurring somewhere in the ballpark of a 18 to 20 second delay. So if you can imagine the insane awkwardness of having to stand up here in front of a group of people, ask a question, and then kill 20 seconds while you're looking at the screen, trying to wait for that reply to come back. And so one of the big accomplishments we saw this morning versus what we did 2 years ago is we were able to cut that delay by over half to make it more of a real-time conversation and to really improve that experience for the viewers and for the speaker and for the astronauts as well. And so when that project was completed, which everything worked as expected, which was great. As an engineer, it's always nice when we plan and plan and plan, and then we install and build these systems, then everything works just about the way we think it will. The relief, as you all know from doing this day to day as well, was quite nice. So when we did the show and delivered that, we told NASA that we're happy to keep iterating on this and providing more in the future, and so let's sit down and think about what the next version of this might be. And with it came out today's project. And so the big changes between what we did then and what we did this afternoon, or this morning, is it was HD. Because it wasn't 4K, the red cam on the space station was damaged that we used previously due to radiation on the sensor, so we had to use the HD camera system instead. And the big difference being, other than that, was that this time we were able to cut out the satellite transmission once the signal was on the ground. So like I said, the content travels, the traditional TDRS NASA transmission method to get it down from the ISS, but once it's on the ground, we had to then re-engineer how we were going to get that content to us here in LA. And so because of that, we utilized one of our new media services called Media Connect, which is a reliable and secure video transport system or tool in the AWS media services, and was able to essentially connect these dots between where's our ingest point, how do I get it across the country, and how do we decode that and pull it back out. And so we utilized Zixi transmission through this service, and we're able to ride the public internet between the egress point at Johnson Space Center and then the ingress point here in Los Angeles. And then in between, it rode on the AWS Media Connect to get us between A and B. So after a lot of testing, we found that this was actually proving to be slightly faster than satellite, and it was providing us with the resiliency and reliability we needed to get the content to us here without a sat truck, without transmission costs that are incurred with that. So because of this, said, okay, well now we have this really big piece of the puzzle figured out, and it's something that's not a one-off solution. It's something that we can replicate and provide to you. I put out a blog post this morning after the project was done, which you're welcome to go through and read and study and take a look at all of the workflows that I created for this, so that way you can replicate it or iterate on it for your own needs as well. And so with this bigger piece of the puzzle in place, we're able to then go through and plug in the rest. And once the content was decoded on this side, we're able to put it into the production plant here, the switcher, routers, and everything else, produce our entire show around it, just like we did previously, and then allow for a faster conversation between Dylan and Rodney with NASA and then the astronauts as well. So by, again, cutting out a lot of that delay, it improved the experience for everyone involved, including the audience. And then we were able to take all of this that we were producing, send it back through our cloud services, and then deliver that to the viewers. So with the cloud services, one of the things that I personally like about it is that we're able to offload a lot of these hardware costs and provisioning costs that are traditionally associated with doing live TV to the cloud environment. So for those of you, I guess, first of all, show of hands, how many of you are using the cloud in some extent on your workflows today? Okay, so I'd say roughly half the audience. So for those of you who are using it, as you know, you're able to turn these services on, utilize them, fine-tune them and tweak them, and then turn them off when you're done if you wish. For those of you who aren't familiar with this process, that is a real game changer in a lot of ways, because you're able to then save, instead of having to buy like a specific piece of hardware, hold on to that, maintain it, pay for the power and the cooling and everything else for it, you're now able to turn these services on, use the service as you see fit, and then of course turn it off when you're done. So you're not incurring a lot of residual cost outside of the usage for it. And so with this, as we're creating these workflows, we're able to turn these on, test them, iterate on it, design, tweak, fix things, and then turn it off when we're done, and I'm not burning through a lot of extra cost while we wait in between our testing cycles. And so that's what we were doing in the last 2 months of this project, of working with NASA and working with our teams and SMPTE as well, to essentially plan out how we're going to do this, test portions of it at a time, tie it all together, test it, and then when we were done with our testing, turn it all off, and then redeploy it again when we got here on site. So rather than carrying a bunch of encoders around with me from LA, because I live in Denver, so rather than flying around with a bunch of encoders, I'm able to bring a few smaller contribution encoders, do everything else on site, turn everything on the cloud, produce the content, and produce the show and deliver the show, and then make that available in a VOD state later on, turn it all off, and I fly back with a contribution encoder. So it's, from an efficiency standpoint, it's become a lot more flexible and a lot easier to go do these events and do these programs in a situation, again, that is variable. We don't have a venue here with satellite downlink and a Zixi fiber, or not Zixi, but a Vivex fiber circuit, or what we would traditionally use in a lot of venue environments. So we're able to use the tools we have reliably, connect all these dots, deliver content, provide a great customer experience for the viewers and for the people involved, and then also provide you with a workflow and a template, so that way you can take it and run with it later on down the road, if you so choose to use these same types of services. And so that's, in a nutshell, how we got from 2017 to today, and then how we were able to deliver the show today. The aspect of this is that, or one of the fun aspects of this is that, these are evolving as well. So what we'll do is we'll take what we did today and go back to the drawing board and say, okay, how can we fine tune this a little bit more? How can we cut down the latency a little bit more? How can we ensure that we have no packet loss while doing that? How can we ensure that the picture quality is going to be as good, doing the same thing, and then also providing in all these different formats as well? And so, there's, as you know, with broadcasting, there's never a truly finished project. We're always going back to the drawing board on these things and reapplying new ideas, new codecs, new architecture, new tools for doing that. I did post a blog post this morning after the event was done that provides an overview for this and what it took to get it done, which you're welcome to take a look at on the Amazon Web Services media blog. And then we also will be making the content available for viewing later on as well. So if anyone has questions, you're more than welcome to step up here.
What about from their side? What was going on with were they seeing any image from us or just hearing the audio And if they were seeing anything, what was their latency on their end too?
Yeah, so we were not sending video back to them. We were only sending audio, and that's a traditional NASA workflow. And then the latency, Rodney and Dylan, back to them is roughly 650 milliseconds, he says. So, so it's pretty fast in the big scheme of things.
So not all the events that they do with the space station are done to a private audience like this. Many of them are done in a broadcast context. Mm-hmm. And I'm wondering if you have an opportunity to reduce half the latency in this by producing two parallel streams of video. One would be low res, much less latency, which would be exposed to the producer, the person asking the questions, so that they could reduce that turnaround time back and then make that latency more tolerable for the audience that would be watching on a broadcast channel at full res.
Yeah, no, that's absolutely possible. So one of the things I failed to mention is that in this similar workflow, we do have complete redundancy across multiple regions of ingress and egress points. So if we were to have lost one of the signals, we could just immediately flip over to the other signal. Now, to your question's point, though, what we could have done is sped up one of those by reducing the latency, which of course risks additional packet loss. But if you're using it just as a confidence monitor or as an internal tool for Q&A, you could turn that dial up and reduce the latency even more.
Okay, Thomas Edwards from Disney. So were we watching HLS or MPEG-dash packaging?
For this, you were watching H.264. So what we're doing is TS, just traditional TS segments, to the venue. Now, the viewers watching at home on the live stream did watch HLS.
Thanks.
Mm-hmm. So, yes? Yeah, so the question was, were we using Zixi or Media Connect? We were using Media Connect to transit the content from Johnson Space Center to us here in LA, and that was with the Zixi protocol through Media Connect. This was just a quick overview of what we did back in 2017 with the 4K version of this project. Testing, launching, installing, testing again, doing the show, and then providing that content on the output. Of course, the challenges of working in space, as Rodney and Dylan pointed out earlier from NASA, is that you have lots of constrained pipelines, you have a lot of variable environment issues that take effect on this. And of course, this is the first time at that point that we had done 4K from space. So were these connections and these pipelines and these encoding instances going to work the way we predicted that they were going to work, which thankfully they did. Like I mentioned, we did have to take essentially our data center class machine and shrink it down to a much more smaller form factor and less power consuming version of that encoder. And so what our engineering team in Portland, Oregon came up with was this 180 watt version that was about 10 pounds, 12 ounces, and that's what's sitting in the space station right now. So here's the workflow for the original 2017 broadcast. So as you can see, we had satellite transmission in there. We had multiple ground encoders along the way. And at the time, the only thing we were doing in the cloud was just packaging. So the origin service, for those of you who aren't deeply familiar with how streaming works, the origin service and the packaging service is where, once the content egresses the encoder, is held and awaits for the request from the viewer. So at the time, we had a variation of our cloud service called Delta on AWS, and Delta was a lifesaver in this project because we just weren't sure how many people were going to watch. And what ended up happening was, as I'll show you here in a few minutes, is that we had a lot more than what we thought we would. And so by putting the origin and packaging service in the cloud, we're able to help prepare ourselves essentially for a larger audience than what we thought we would. But that was 2017. That was version 1 of this workflow. And there's the encoder in the bottom right, what it looks like when they have it out sitting there in the space station. And then here's a little bit more detailed look of how we got the 4K and the HD audio for the audio stream down to Johnson with NASA's help, utilizing their service. So everything from the ISS to Johnson is on the NASA network. That's their network and their system. Once it egressed Johnson Space Center, though, that's where we pick up the service at that point. So in this case, we had 2 encoders on the ground after they were combining the audio with the video, syncing everything back up, and then we'd send it to Las Vegas. Then once in Las Vegas, we had a dedicated fiber line that was serving as our backup. Then we had a satellite transmission at the time from Encompass in Atlanta, who is NASA's production partner as well. Then we produced the show and then sent it back out on 2 encoders. And of course, the first time, once we got those first shots in 4K with Commander Whitson, it was pretty amazing. You could feel the excitement in the room as we turned that on the first time and saw everything working from end to end, which was pretty spectacular. And then this was our small production control, master control setup in the back of the room, just to manage all of the different pieces that we had in play at that point. And so the latency was the hard part, and dealing with the latency. So I'll let you take the audio there if you can, but this is Sam, who is our co-founder of Elemental
Space Center,
Technology.
can you do the audio check? Coming. We should hear it in the room very shortly.
Station, this is Houston. Are you ready for the event?
Yes, we're ready for the event.
Please call station for a voice check.
Okay, here we go. Hello, Commander Fisher and Commander Whitson and Colonel Fisher. It is an honor for all of us and those online to join you and all of your colleagues at NASA in the first ever live 4K stream from space. What is the ISS position in orbit right now? "11 seconds.
So that gives you an idea of just how much latency we had in the first iteration of this workflow and how much more we were able to cut it down for this morning show versus that first version. So like I was saying, how we used the cloud in 2017, we were doing just packaging in the cloud. And this was on a former product that no longer exists, and it's called Delta. And Delta was a very good packaging service, but we've since iterated on that and improved it to provide what we have today. But at the time, we had to provide all these other additional tools in it, like Route 53 and additional regional caching rules for the edge services with CloudFront, which is our CDN. And then this dives a little bit deeper into that. Okay, so if you're going to do a live event that's really large and you're promoting it, you're going to want to ensure that it's actually going to be resilient. And so we utilized a multi-region setup within the cloud, within the AWS cloud, and had a Route 53, essentially a DNS switch, to switch between those 2 regions if we lost one entire part of the workflow. It was a pretty clunky switch if we had to switch it, which thankfully we didn't. Then the player then you as the viewer would have to restart your player. So we were really hoping that no switches were going to be needed, and thankfully they weren't. But that was the backup, is that we wouldn't lose the show entirely. There would just be a buffering instance. You'd restart the player, and you're back to normal and watching. Here's just a quick look at the ABR stack that I created for the original show. We did an Ultra HD and then a cinematic 4K frame size there at the bottom. And this was HLS H.264 as well. And that's because of how prolific HLS is. the backhaul and the transmission between Johnson and the location were HEVC, and we use that again today in the backhaul. But when it goes out to the viewers, we still use HLS because of the amount of devices out there that still require HLS. And so, as all these great new codecs come online and they really are extremely efficient and doubling the amount of quality we can get into the same bits, there's always that roadblock of, okay, well, how many people have the device to watch that content on that super cool new codec? So that's why we still use HLS in a lot of these shows for the final end delivery to the viewer. So, like I mentioned, we weren't sure how many viewers we were going to have on the original show with the 4K version. So as soon as we turned the video player on, which is around 8:58 there, you can see where it just started taking off. We had quite a bit of demand, and so we thought, okay, it'll probably level out somewhere around 60,000 kilobits per second. We'll see what happens. Then we got into the show, and we ended up exceeding 1.5 gigabits on the output, which was far beyond what we would have ever expected. So if we had done that on the ground with a ground packaging server, we probably would have crashed the show because we wouldn't have had enough bandwidth to actually deliver all that content from a venue like this with the internet service that's available. Where with this, we're able to use cloud to expand and grow the back-end services required to deliver that amount of content to that many people. And with this, what it also showed us is that by rough calculation, you could tell that someone was watching from almost every CloudFront region around the world, which was pretty astonishing. It's not something we expected on the first version of the show. So because of the fact that we had so many people watching, it really provided a great test case for how well the elasticity is when it comes to the demand and how the cloud service can grow to absorb that demand and ensure that everything was delivered as we promised without having to essentially lift a finger on our part. We're still doing a show behind the scenes. We're not back here quickly configuring switches or panicking over the amount of bandwidth that we're going to have to pay for. And then, of course, everyone was happy at the end of the day, which is what you want. But we got great results from the original show, and it was really great to see, again, that first iteration of the architecture worked so well, and they gave us a lot of feedback in a good way to then go back and see what we can do better in the future. And so let's fast forward to today's show. Like I mentioned earlier, here's the architecture that I designed for this morning. A couple of changes on it. The encoder used on the ISS was not our encoder because we weren't using the 4K camera. But everything else in here is accurate. So what we had in the top left corner was, of course, the stream coming down across NASA's proprietary network to Johnson Space Center. And then once at the Space Center, we were able to utilize that Zixi transmission to send to us here in Los Angeles via Media Connect. We decode it out here, put it through the production, re-encode it, send it back to Media Connect in the respective regions, and then, of course, encode that ABR stack for delivery to the viewers at home. Where it stops for us here is that you just saw the output on the screen, but we also were producing a live show around this as well for viewers who couldn't be at the venue today. So this is a workflow that I've included in my blog post if you want to go take a look at it or save it or read about it a little bit further. And in each region, you can also tell that this time we're utilizing Media Live and Media Package. So Media Live is the cloud-based transcoder. So rather than creating an ABR stack on the ground and eating up a bunch of bandwidth to send that to the cloud, I'm able to create a really thin mezzanine contribution stream in each region for redundancy, and then create my ABR stack in the cloud, which of course saves on bandwidth and hardware cost. And then Media Package is what replaced Delta in the origin service for AWS. So now we just naturally use Media Package instead of Delta. We're also sending an archive output to Amazon S3 storage. That's just a standard MP4 archival save of the show. So that way, again, if we lost one of the regions, everything was backed up on a redundant region, which gets us to the very end here. And for those of you familiar with streaming, maybe scratching your head wondering why we have two CloudFront endpoints going to the viewers. What we actually have in between those is a new solution that's still being developed, so we haven't released it yet, but we did use it this morning and it worked great. It's called HLS Copilot, and Copilot allows us to switch between regions with HLS streams. And where I said before that we had to have the viewer restart the video player when we had a regional failover or a regional failure on the first iteration of the workflow, this new iteration allows us to, in one button push, switch the contribution from region 1 to region 2, and it's a clean switch to those viewers, so there's no negative effect on the viewership or the viewer's experience at the end of the day. Now, they're not perfectly in sync, so you're going to see a little bit of a glitch, probably by a second or two, but it's a really clean solution for allowing us to switch between regional HLS streams without destroying the entire viewing experience. Again, a comparison for what we did in 2017, which was utilization of satellite, and then what a lot of traditional workflows include, which is hardware encoders, hardware packagers, and then of course your network infrastructure at your broadcast facility or venue to deliver that content. The new cloud solution allows me to utilize these tools in a much more elastic way, which of course gives us flexibility for architecture, operations, and cost savings because, like I said, turn it on, use it, turn it off when I'm done. Or with the traditional hardware, I'm stuck holding onto that hardware before and after the show. So a difference here in transmission, like I covered a little bit ago, is that you would usually perform like MPEG-2 or MPEG-4 transmission over satellite. With the cloud DA service, Media Connect, I'm allowed to essentially use Zixi or Wrist. I chose Zixi for this project, but you can use Wrist as well. And it allows me to perform the exact same function for contribution, but over IP and public internet without the need for dedicated fiber lines or satellite transmission or reception. And so it works in the same theoretical sense that you're going from point A to point B, but the other really cool thing with the cloud service is that I'm able to add outputs. So if I have, let's say I have a new affiliate site somewhere on the other side of the country that wants to take this down and someone calls me 10 minutes before the show starts, I can just log in, spin up an output, which literally takes 5 minutes, and now we can light that affiliate up in real time and have that content distributed immediately to that affiliate site, and with either a hardware decoder or to another cloud service or to another cloud transcoder if they so wish to use it. So the flexibility benefits you can see are pretty staggering compared to a traditional satellite setup because of the fact that you're not having to pick up the phone, call the satellite operators, and booking new windows and new destinations. From the encoding side, as we touched on earlier, by utilizing a cloud transcoder, they're doubled, and that's because of the inherent redundancy and resiliency that's built into our services that I used this morning. Within the way AWS regions work is that there are availability zones within regions, and those availability zones are where essentially the data centers are. And so what a lot of these services do is they replicate across availability zones. So you're not sitting in one data center, you're sitting across multiple data centers to ensure the resiliency of that stream or that service or that content or that storage. And so that's why you see 2 transcoders and 2 packagers, as those are representing my 2 instances across the availability zones within one region. So if you really want to get into the details of this, I have a link in the blog post about it as well if you want to learn more about that. But essentially, it's quadruple redundancy because I have 2 availability zones within each region, and I'm using 2 regions within that. And so that gives you an idea of how much redundancy we're working with in the background to really replace what is a more traditional, or at least previously traditional workflow. So benefits of using the cloud that I personally enjoy are the automated redundancy. So like I said, as demand scales, the elasticity of the services scale to meet that demand. So it allows me to turn it on and then just keep an eye on it. As the demand grows, that service grows out and provides or meets the demand that's required. The scalability touches on that as well. We can add as much to this or scale it down to one instance if we want. The accessibility from anywhere, I could be at home in Denver and log in and manage the same tools that I was here keeping an eye on from the cloud service today. So you can now have distributed workforces that help manage your services and manage your delivery or your transcoding from theoretically anywhere in the world with an internet connection. And then the fast deployment and teardown. Again, once we do these, we can turn them on, do the show, turn it off when we're done. And then we no longer need a ridiculous amount of bandwidth at the site. We had 50 megabits down and 50 megabits up this morning, and we did the entire show with that for my ingress and my egress on 2 encoders here and 2 decoders here. And then I'm physically happier because I don't have to run around with additional hardware now. So it saves me cost and flying, so I'm not trying to check additional bags and boxes and things like that. So that's it's a quick overview of what we did in 2017, what we did this morning, and the differences between those. And of course, with our great partners at NASA, we love working with that team. Everyone over there from NASA TV to at the Johnson Space Center to headquarters, they have been phenomenal partners to work with and allowed us to provide these proof of concepts that can prove out future workflows for them to deliver any stream from theoretically any place that they want. And then of course SMPTE, Joel Welch back there, who helped get all this together and provide us the venue to do this in, has been great as well. And so thanks to everyone. Thanks for joining us. I hope all of you enjoyed the show this morning. And if you have questions, feel free to let me know or shoot me an email. So thank you very much. Any other questions before I jump off? Okay.
I was just curious if you could talk about how you switch between the 2 ABR streams. Are you essentially modifying the playlist and then the device just changes where it's pulling from, or is it something else?
Yeah, so it's not to get too far in the software development side of it, but what it is we have two manifest playlists, and then what we're doing is we have there's another AWS function called Lambda, and Lambda is a serverless compute service. And what we're doing is we're probing each of those manifests. So when we get a 404 error, we know that that stream's now stale. We need to switch over to the other one. And so I have a little monitoring dashboard that's custom built that we're going to hope to include in the solution when we release it, that allows you to keep an eye on those streams, and then you can monitor it, and that probe will tell you whether what's going on and when you should switch.
So then if the probe shows a 404, you just pop the other source into the playlist and push it out, and that's it.
Exactly. We essentially clear out the original that's erroring if it were to error, and then we are fresh on the new one.
Thank you.
Yeah.
This might be more of a question for NASA, but how many ground stations are there for communications with ISS?
I am not sure. Just one? Is it the one in New Mexico? Okay.
So
yeah.
When the ISS is on the blind side from Johnson, how does the signal get from ISS to Johnson?
Yeah, TDRS. Yeah, it's a satellite hop down to New Mexico.
Hop. Thank you.
Yeah, geosynchronous satellites, as Rodney says.
Thank you.
Yeah.
So being the archivist in the room, I've got to ask the unasked question, which is, keeping things in the cloud is fine, and it's going to sit there for a period of time, and in fact, it could be archived there for a period of time. Was there any thought for planning of these events where there would be certain portions of this or all of the data would go over to NASA and be part of the planetary data set or one of their sub-archives?
Yeah, so we provide everything that we record to NASA, and then as far as everything that's coming from them, they're archiving as well and maintaining. So we make everything that we captured today available to them. Okay. Any other questions? Okay, great. Well, thanks again, everyone. I really appreciate your time.